Hi, this is Mr. Chen. You're welcome to my study room. If this is your first time of visiting here, then I would strongly encourage you to subscribe to my channel, Mr. Chu Study Room, so that whenever I upload a new video, you'll be notified immediately. Thank you. Today's studies is session 4 of exponential equations, and we are solving exponential equations that end up in simultaneous equations. Let's go straight to the lesson. Thank you. In question 1, we have to find the values of m and n satisfying the equations 3 exponent m times 3 exponent n equals 243 and 3 exponent m divided by 3 exponent 2n equals 9. Here, because we have two variables, m and n, and then we have two equations, this should give us a hint that this is going to be simultaneous equation, or this is going to involve simultaneous equation. So let's go ahead and get our equations from the equations given here. We start with the very first one, or we rewrite the equations as equation 1 and 2. So we're going to have 3 exponent m times 3 exponent n equals 243. Let's make this our equation 1. Then we go to 3 exponent m divided by 3 exponent 2n equals 9. Equation 2. Now, let's develop our linear simultaneous equations from equations 1 and 2. We take equation 1 first. That is 3 exponent m times 3 exponent n. We are first expressing this so that they will all have the same base. I think 243 is 3 exponent 5, or let me just check. Yeah, so 3 exponent 5 is 243, and that is 3 exponent 5. And then from the laws of indices, since the base, or we can even simplify further before we even equate the bases to be m plus n because of the multiplication, giving us 3 exponent 5. So here, since the bases are the same, we equate exponent. So m plus n will give us 5. Let's make this our equation 1. No, sorry, we have equation 1 and 2 there, so let's make this one our equation 3. Then we take equation 2 to break it down to get a linear equation like this. So that is 3 exponent m divided by 3 exponent 2n will be equal to 3 exponent 2, which is equal to 9. We simplify the left hand side to get 3 exponent m minus 2n because of the division. Then equals to 3 squared. Then because the bases are the same, we equate exponent to get m minus 2n be equal to 2. Let's make this one equation 4. I'm just coming to write the equation 3 under the equation 4 for easier calculation. Good. So here, it's up to you to determine whether you want to use substitution or elimination method. But here, I'll use substitution method. So from equation 4, m will be equal to 2 plus 2n, because I have moved this -2 to go and join a 2 here. So that's where I got it from 2. Let me make it equation 5 just for easier identification. So I will now substitute equation 5 into equation 3. Remember, I cannot put it into equation 4 because I got equation 5 from equation 4. Or the equation 5 is the same as equation 4, but only that I made m the subject. So I cannot put it back into the same equation that I got it from. So I have to put it back. I have to put it into the next equation, which is equation 3. So that means that wherever I see m in this equation 3, I'm going to fix 2 plus 2n into it. So our equation 3 now becomes 2 plus 2n plus n equals 5. We make n the subject. This will be 2n plus n, they are like terms, so that will give us 3n be equal to 5. This one goes to the right, become minus, so -2 become -2, and 3n will be equal to 3. We divide both sides by 3. Our n will be equal to 1. So let's just do that on a fresh sheet. Oh no, let's keep it here so that our work will look simple on one sheet. So now we are going to put n equals 1 into either equation 3, equation 4, or equation 5. Any of them will do. So let me put it into equation 5. That means our equation 5 now becomes m equals 2 plus 2, wherever we see n, we fix 1. And that will give us 2 plus 2, which will give us 4. So we'll conclude that therefore our m equals 4 and n equals 1. So this is our equation, or our solution to the question. We can also use the elimination method. Okay, probably so the question 2, I'll use elimination method to solve. Let's take question 2. Question 2 says that if 4 exponent x times 2 exponent y equals 64 and 32 exponent x divided by 4 exponent y equals 16, write down 2 equations connecting x and y, and hence find x and y. The same analogy here. The fact that we have x and y and then we have 2 equations should tell us that this will make us get 2 equations which we can get the answer by solving simultaneously. Let's go and do it just like we did question 1. We rewrite our question 4 exponent x times, let me just rewrite 4 exponent x times 2 exponent y equals 64. Let's make this our equation 1. Then 32 exponent x divided by 4 exponent to y equals 16. Equation 2. We take equation 1 now. We take it by expressing each of them as a common base. And I hope you understand that the common base here will be 2, because 4 exponent 2, or 4 can be expressed as a base of 2, and then 64 can also be expressed as a base of 2. Here is already 2. So this will be 2 exponent 2x, that is for the 4, then times 2 exponent to y will be equal to 64. I think it's 2 exponent 5. Let's just verify. 2 exponent 5, and let's see. That's 32. So it's 2 exponent 6. 2 exponent 6 is 64. So we are going to use that for 64. So that is 2 exponent 6. We work it further. 2 exponent 2x plus y, because of the multiplication, will give us 2 exponent 6. Bases are the same, so we equate exponent 2x plus y will be equal to 6. And this becomes equation 1. No, equation 1 and 2 already there again, so this will be equation 3. Remember, the number of equations doesn't spoil anything. You can get equations up to 10, it doesn't matter. Anytime you name an equation, it only means that you've not finished with that equation, so you come back to it. And because of that, you are giving it a name, so that whenever you say we should substitute something into any of them mentioned earlier, everyone following you will know where exactly to substitute that. That is just the meaning of equation. So let nobody be confused by the number of equations we get. The number, we can get as many equations as possible. Yours is to name them rightly, rather, so that whenever you fix something into any of them, it will be very obvious where we are substituting the thing. Let's take equation 2 and break it down to get equation 4. 32 here, we can be expressed, also be expressed as base 2. So 32 is 2 exponent 5. Let me rewrite that first. No, let me just write 2 exponent 5. 2 exponent 5x for the 32 exponent x divided by 2 exponent 2y, then equals 2 exponent 4 as 16. You can just verify that to be sure. Always use the calculator to verify your answers. So 2 exponent 4. Because there's no special award for thinking from your head. It makes it faster. But it's more important when you verify with the calculator and you are very sure of your answer. So this will give us 2 exponent 5x minus 2y being equal to 2 exponent 4. And then bases are the same, so we equate exponent to get 5x minus 2y equals 4. Equation 4. Again, let me just write equation 3 under it so that it will be easier for us to work with. Plus y equals 6. Equation 3. Don't increase it, because this is just this equation we are repeating, so it should still be equation 3. Now here I promise to use elimination method, and I want to eliminate y. And for that matter, I have to make the coefficient of y here be the same as coefficient of y here. And the coefficient of y here is 2. Coefficient of y here is 1. The LCM of 2 and 1 is 2. So to make here 2 to be 2, I have to multiply through equation 3 by 2. So I'll write that equation 3 times 2, or multiply equation 3 by 2 is the same thing. And that will give me, that 2 times 2x will give me 4x. 2 times y will give me 2y. And 2 times 6 will give me 12. Again, a new equation is formed. So let's make it equation 5. Remember, equation 3 is what we turn into equation 5. So we cannot do anything with equation 3 together with 5 that we got from it. So I'm coming to write equation 4 under it. Then I can do what I wanted to do now. 5x minus 2y equals 4. This is equation 4. So I'm just writing it closer to 5. Now, the coefficients are the same, but the signs are different. So we add to eliminate y. They say when the signs are different, you add. So you add to eliminate y. Because of that, so I will write equation. Remember, this is not addition. This is just a tip of my pen when I was explaining. So this is minus. So we'll add them. Equation 4 plus equation 5 to eliminate y, because the signs are different. This is positive, this is negative. So 4x plus 5x will give us 9x. Then 2y plus negative 2y will be 0. So we have eliminated our y. Then 12 plus 4 will give us 16. We want x and not 9x. So we divide through both sides by 9. Our x will be equal to 16 over 9, which will be the same as 1 whole number 7 over 9. That is our x. Let us substitute that into any of the equations. So I'll substitute it into equation 3. And we are saying that we should put x equals 16 over 9 into equation 3. So that's what it means that whenever we see x in equation 3, we put 16 over 9. So equation 3 now becomes 2 into bracket 16 over 9 in place of x plus y equals 6. This will give us 32 over 9 plus y equals 6. So we group like terms. Our y will be equal to 6. This one goes become minus, so minus 32 over 9. This is subtraction of fractions. So you find LCM. Our LCM is 9. This is 6 over 1. So 1 going to 9 times. 9 times 6, that will give us 54. Then this 9 will go into itself 1. We bring our minus. Now we go into itself 1. 1 times 32, 32. So 54 minus 32 will give us 22 over 9. So therefore, our y will be equal to 22 over 9, which is the same as 2 whole number 4 over 9. We will therefore conclude that therefore x equals 16 over 9 and y equals 22 over 9, or we express them as mixed fractions or decimals. That one is dependent on whatever you want to do. So after this question, some questions will be displayed on the screen for you. Please take your time and apply just the procedures you have used to solve and feel free to share your answers with me in the comment box. I'll be glad to see that. So here are the questions. Good. Thank you for watching. Don't forget to subscribe for more videos. Hope to see you again. Until then, bye bye.